Hello, welcome all of you. Today we'll start modern physics. That is one more section of your physics, 11th physics. Then out of this, 5 chapters are there, which belongs to your second part of 12th physics, and one more chapter that is from first part. Chapter is electromagnetic waves. Electromagnetic waves. Now don't worry about this chapter. This chapter is full on theoretical and statistical. Now stat म्हणल्यानंतर आणखी किती वाटेल तर असं काही नाही, just you have to remember few mathematical data, but analytically if you study it is very easy. Here a chart will be given and one side of the chart there is the numbers representing wavelength of different radiations, different rays, and on one side frequency will be given. So frequency and wavelength, and the chart will be like this. Suppose this is the band of visible waves, visible light. Visible consists of VIBG by OR. Okay, visible rays that we can visualize or we can see from with our naked eyes. And then different rays will be there in a sequence like X-ray, microwaves, alpha rays, beta rays, gamma rays. So different infrared rays, ultraviolet rays. So different rays will be in a specific sequence, and based on that sequence, the different wavelengths will be there and different frequencies are there. So you just have to remember that sequence. So as in what order the wavelength increases, in what order the frequency increases or decreases, same as you have remembered in dispersion of light, like VIBG by OR. Inside the visible spectrum, you know, red is having highest wavelength and lowest frequency, and violet is having highest frequency and lowest wavelength. That you know, the order. Same त्याच प्रकारे इथे तुम्हाला भेटायला एक ऑर्डर रिमेंबर करावी लागणार आहे, and that is the आणि किती wavelength आहे. Mostly statistical data विचारला जात नाही की exact wavelength किती आहे, but order विचारले जाते की which one is having highest, which one is having lowest, which is the correct order, increasing order, decreasing order. म्हणजे तुम्हाला समजलंय की नाही याच्यावरती जास्त फोकस असतो. एक्झॅक्ट or what can say कन्सेप्शन क्वेश्चन याच्यावरती बनवू शकतात. डोंट थिंक याच्यावरती म्हणजे डायरेक्ट क्वेश्चन असा आहे की याची व्हॅल्यू किती आहे. ठीक आहे, व्हॅल्यू विल बी गिवन इन द क्वेश्चन इटसेल्फ इफ न्यूमेरिकल इज देयर. नाउ आणखी काय म्हणजे असणार आहे की एखाद्या रेंजचे जे पार्टिकल्स आहेत त्याचा चार्ज किती आहे, मास किती आहे, व्हॉट विल बी द चार्ज, व्हॉट विल बी द मास, देन wavelength, frequency. Okay. So for each wave we have to study the properties of alpha, beta, gamma, X-ray, microwaves, infrared rays, ultraviolet rays, then visible spectrum, X-rays. So don't worry about this chapter. We will conduct this chapter at the end of our syllabus. Now, when we come to modern physics, that is our second part of physics, 12th class physics. Okay. Now, whatever we have studied in first part, what are the chapters we have studied in the first part? Electrostatics, current electricity, magnetic effect, electromagnetic induction, alternating current. Those all chapters are belongs to electrical engineering. When you go for electrical engineering, that all chapters belongs to that. Now, like 11th class syllabus, the whole 11th class syllabus will be for mechanical engineering, automobile engineering, aerospace engineering, production engineering, thermal engineering. So lots of branches you can go for when you study NEET the 11th class syllabus. Now first part of 12th I have told you that is electrical engineering. Now this is the second part. Inside the second part, 2 chapters we have studied, that are ray optics and wave optics. Now when you go for ray optics and wave optics, that are also used for research when you go for BSc, MSc and further research in physics. Also atoms, nuclei and dual nature, these 3 chapters with ray optics and wave optics. With ray optics and wave optics, when you go for any research purpose, like if you are not going for engineering, you just want to do Bachelor of Science, then Master of Science, and then for PhD, then ray optics, then atoms, nuclei, and dual nature. These are the very much important chapters. Now, what about semiconductor and communication? Semiconductor and communication. You know, in your college, most of the in junior college, state board, or even you also have some people of you have an optional subject, that is computer science and electronics. So for electronics engineering, semiconductor and communication are very important chapters. Semiconductor and communication for electronics and telecommunication branch. Okay, so there is electrical and electronics. In between these two, there is a huge difference. Okay, whatever the circuits or power supply is from electrical, and what is the modern technology, that is LED TV, LCD TV, computers, laptops, mobiles. So all are based on electronics, or car music system, anything. Okay, or any satellite purpose, everything based on electronics. Okay, so we are going to start with semiconductors like electronics and modern physics. This part will keep after these two chapters. Okay, so why? Because atoms you have studied in 11th class chemistry, that is structure of atom. There you will have the name structure of atom, you have the name, and nuclei, that is in nuclei what is the main content, that is radioactive decay of nucleus. Radioactive decay means every nucleus emits some radioactive rays. त्याचा यूज कुठे होतो? एखादं कॉइन सापडले म्हणजे ह्याच्यामध्ये जमिनीमध्ये, ठीक आहे, किंवा काही मूर्ती सापडल्या खूप वर्षापूर्वीच्या आहेत, that are belongs to ancient history. So what is the age of that coin? What is the age of that monument, or what is the age of that idol? काय एज असतं, किंवा काही ज्वेलरी मिळाली त्याचं एज किती आहे, किंवा स्केलेटन, ह्युमन स्केलेटन जर सापडलंय का, खूप वर्षापूर्वी खून झालाय का, आणि अचानक काहीतरी शेतीमध्ये खोदताना तो स्केलेटन सापळा सापडला. सो कधी खून झाला, हा ही डेड बॉडी किती वर्षापूर्वीची आहे. So to recognize that the concept radioactive decay, so every nucleus emits some radiations. So त्याची एक लाईफ आहे की तो जर ताजा असेल, नवीन असेल, तर तो रेडिओएक्टिव्ह डिके फास्ट करत असेल. जर 2 वर्षापूर्वीचा असेल तर आणखी स्लो करेल, त्याच्यात आणखी पाठीमागचा असेल तर थोडा स्लो करेल. And based on that speed of radioactive decay, we are going to determine the life of the that matter. That we are studying first order reaction, second order reaction, third order reaction, chemical kinetics. So this chapter atoms, that belongs to structure of atom in 11th class chemistry, and nuclei, that belongs to chemical kinetics of 12th chemistry. Okay, and dual nature, like a few days before, me and Rao sir, we are discussing on group about photon. Photon is not proton, electron. It is not like that. Photo means light. Okay, photograph कसा घेतला जातो? तुमच्यावरती लाईटचा फ्लॅश पडला होता, तुमच्यावर जी लाईट पडते ती रिफ्लेक्ट होऊन कॅमेऱ्याच्या होल मधून येते आणि त्या फिल्म वरती प्रिंट होते. So photon means light, like photosynthesis. Okay, so photon means a particle or bunch of or packet of light particles. Okay, so some scientists think light is a waveform, light is in a waveform, or some scientists think about light is a particle nature. Wave means it doesn't have mass, particle means it should have some mass. And then after that those two scientists, a combined theory was established, that is dual nature. Dual nature means light is having both particle as well as wave nature. Okay, so we will discuss whatever that. So these 3 chapters we will conduct after the semiconductors and communications. Okay, otherwise what we'll do one thing. This electromagnetic waves, that is is our first part chemistry, and waves we need in communication. In communication chapter we need waves because communication is satellite communication. Okay, so from transmitter and receiver. What is transmitter? Which transmit the signal, and receiver is your dish antenna on your roof, on terrace. So transmitter is a tower. From tower signals are transmitted and that are received by dish TV or any antenna. Okay, so or area of radio. So these waves are very much important in communication. So what we can do, we can take electromagnetic waves and communication simultaneously. This chapter we will take together. First we will conduct semiconductors. After semiconductor we will do atoms, nuclei and dual nature. And at the end we will do electromagnetic waves and communication. Here also these two chapters are also carried. Communication is also very interesting chapter. Here we are going to study what is AM, what is FM. You must know about FM 98.3 Mirchi and all. And AM is like Mumbai Akashvani Kendra, Kolhapur Akashvani Kendra. So these are the government channels. That is AM, amplitude modulation. And FM is frequency modulation, and then PM is phase modulation. Okay, so these three we are going to see in communication. And also what are sky propagation, what is space propagation, what is ground propagation. So all the theoretical parts we are going to see in communication chapter, and that are based on electromagnetic waves. So these two chapters we will take simultaneously. I will not talk about semiconductors now because I am going to start semiconductors. So after semiconductor we will start these three chapters and then this. Okay. Okay. Now about levels. I have an RIDA book in front of me. So, before in 11th class, we have 1, 2, 3, 4, 5 levels. Total 5 levels. But I am observing that in all those chapters which I have written here, there are only 3 levels, like level 1, level 2, level 5. Direct 5th level is there. Okay, in homework. Okay, level 1, level 2, level 5. And in some chapters there is level 6. So level 3 and 4 are missing. They are missing over here. So direct 5 and 6. Okay. So in semiconductor if you see, there are only 2 levels. Okay, and in third level only 2 matrices are given. Matrix, that is match the column. So only 2 questions are there in the third level. So only 3 levels are there. So don't say like we are not conducting 5 levels. So after first and second level, direct there is 5th level. Okay, in atoms, molecule and nuclei. So I will tell you. In dual nature, we have 1, 2, 5 and 6. Then atoms, nuclei and semiconductor. And I will tell about communication and that book is, I am not having that book, so I will discuss that afterwards. That are the homework levels. Okay, homework levels. Homework levels. So here also third and fourth level is not given in the book. In atoms, and I will also send you the scan copy of this booklet, topic wise. Okay. So in atoms, level 1. After level 1, level 2 is there. Directly level 5. And after level 5, level 6 is there. So same here, 1, 2, 5 and 6. Now in case of nuclei, here also the same thing, 1, 2, 5 and 6. And in case of semiconductor there are only 3 levels. Third level is not mentioned, but we have 2 questions of match the column. Match the column. So make a note, we are going to discuss this much of levels because level 3rd and level 4 are missing here. Missing, or I don't know what about this book, but 11th class मध्ये असं आहे, ह्याच्यामध्ये 12th class मध्ये असं आहे या चॅप्टरमध्ये. And what about this and plus communication and electromagnetic waves, communication and electromagnetic waves, this I will tell you afterwards, and I will try to finish out this by October end. I will try, okay, by October end. Then the levels of whatever the chapters I have finished, that is from part 1. This I am going to finish by November 15 is the timing target, but let's see what happens. And till the end of December we will complete 11th class. So let us assume that October and November हे होईल, याचा अर्थ November and December we are going to conduct the levels of remaining chapters which I have already completed, ray optics, wave optics, and the first part of the physics 12 physics, electricity, electrostatics, magnetism, okay, plus 11th class. So assume that this is 2 months. Okay. Now, so plus minus there will happen. So make a note, 3 and 4 levels are missing here in this book. Page wise I will send you the what, and this is about JW book. JW, not about, I am not telling about NEET. This is about JW booklet. JW advanced booklet of Narayana. Otherwise, NEET people will say, sir, 3 and 4 levels are there in our book. Okay, so I am just telling about JW booklet. I will also discuss the levels of NEET, which are very essential for JW people in CET exam. Okay, but first of all, we will cover these levels. And the people who belongs to NEET, you just observe the numericals, practice it. बघा तुम्हाला जेवढं जमतंय. If you are feeling the numericals are difficult, then just analyze, study. Okay, don't take tension. Okay, don't take stress. Now we'll start semiconductors. Name itself, it is very easy chapter. Okay. So, one second, I will have some water. So, what are the types of particles? Matter. Some matters are metals, then non-metals. Okay. So, आपण category वेगळ्या handle. So, based on the conductivity, if we classify the metals, then there are materials. Then there are three types of materials. There are conductors, insulators, and semiconductors. So, classification of materials based on energy or band gap energy based on band gap energy. Okay. So remember this word, band gap energy. Now what is band gap energy? Now there are two types of band. Band means suppose place are those places. So some people are standing on platform, railway platform, and some people are in train. Okay, so that means people standing on platform are stationary. Okay, and the passengers which are in train are moving. Okay, so that means the platform and trains are called bands. And platform is called valence band and train is called conduction band. म्हणजे असे कोणतीही प्लेस नाहीये. Actually in chemistry or in this modern physics it is imaginary. एखादा इलेक्ट्रॉन जर तो बॉन्डेड असेल, bonded to nucleus to complete the octet. If an electron is bonded to complete the octet, okay, or to satisfy the valency, then we can say it is in valence band. Okay, आणि तो तिथून निघाला आणि सुट्टा झाला, फ्री झाला, then we can say it is in conduction band. मग अशी कोणती प्लेस नाही, अशी कोणती एका ठिकाणाहून दुसऱ्या ठिकाणी गेला असं आपण म्हणत नाही त्याला. फक्त काय झालेलं आहे, तो इनिशियल स्टेट काय होती, बॉन्डेड होती, फायनल स्टेट काय होती, फ्री स्टेट, लूज स्टेट. So it is nothing like any space or any place. It is just two stages, different stages of electron. Okay, when it is in bonded form, then we can say the electron is in valence band. When it is free, then we can call it as it is in conduction band. So there are two types of bands, conduction band and valence band. But these two levels have some energy difference. This is valence band, this is conduction band. Actually, this is a graph. Now you will come to know what is conduction band and valence band. Valence band and conduction band are not places. कि एखादा इलेक्ट्रॉन वॅलेन्स होता तो आता कंडक्शन बँड मध्ये गेला. हां, तो गेला पण एका ठिकाणाहून दुसऱ्या ठिकाणी नाही गेला. It doesn't mean it move from one place to another place. It means it was bonded and now it is free. That means it is having less energy before and now it is having more energy. Okay, less energy why? In chemical bonding of 11th class you have studied that the atom which is bonded or satisfy the orbit which is inside the orbit bonded is most stable or having less energy. And the electrons which are free are unstable and having high energy. Okay, जे बॉन्डेड नसतात फ्री असतात ते काय अनस्टेबल असतात त्यांच्याकडे हाय एनर्जी असते पण जेव्हा ते स्टेबल होतात अटॅच होतात तेव्हा त्यांची एनर्जी लो होते ते स्टेबल होतात ठीक आहे ना तर valence band on graph I have written so energy is less in valence band energy is more in conduction band that means if any electron is bonded then we can it belongs to valence band when we supply the energy it moves to conduction band now it moves means या place वरून त्या place मध्ये नाही it changes characteristic काय characteristic होती आधी bonded होता आता bonded नाही आहे ठीक आहे सो आणि तो जर फ्री झाला तो जर फ्री झाला then it can conduct the electricity so it must happen in conductors or in semiconductors but insulators we can't so this is conduction band and this is valence band so just write down what is conduction band and what is valence band so this is the valence band first you write valence band is the band of energy level it is the band of energy level of electrons which are bonded in octet or which are bonded to nucleus or which are binding to nucleus okay and then what is conduction band it is the energy level it is the band of energy level of electrons which are free which are not binded to nucleus आता कळलं ही कोणती प्लेस नाहीये इट इज जस्ट एनर्जी लेवल इतकी एनर्जी जर इलेक्ट्रॉन कडे असेल तर तो फ्री असेल इतकी एनर्जी जर इलेक्ट्रॉन कडे असेल तर तो बाइंडेड असेल या इथून जाणं म्हणजे काय एवढी एनर्जी सम अमाउंट ऑफ एनर्जी इफ यू सप्लाय टू इलेक्ट्रॉन्स which are in valence band then the electrons will move to conduction band that means they acquire some energy and becomes free themselves okay so this is the main concept now we will classify the material based on the band gap energy now let's see first one conductors then insulators and the last one semiconductors okay conductors insulators and semiconductors now here the two bands valence band and conduction band are overlapping each other like passengers are standing very near to train what will happen or one leg inside the train and one leg on the platform what will happen they will move with the train so we can say if valence band and conduction band are overlap each other that means some electrons of valence band are free some electrons are of valence band are free so I can write like this is conduction band this is valence band or you can say here this is conduction band and from here it is valence band so conduction band and valence band overlap each other this is the overlapping region that means the electron of valence band which is also in conduction band that means it is free to move example घेतल्यावर लगेच लक्षात येईल आपण असं म्हणूया Fe iron or copper किंवा nickel then D block elements zinc okay which are having some oxidation states like see Zn plus something okay aluminum plus असं काय काय असतं ना Fe3 plus or 2 plus काय काय आहे ना copper 2 plus so these are that means having some free electrons so which free electrons can conduct electricity so here some few electrons which are in valence bands also in conduction band म्हणजे काय they are bonded try to bind to nucleus but which are free so like some passengers try to remain on platform but as one leg is in train that means they will move with the train okay So these are the overlapping. So what first point? What we can write here? So here a band gap is 0. Energy difference between these two gaps is 0. Energy difference between these two bands is 0. Hence, electron which is binded in valence band, it can easily make itself free and conduct the electricity. Okay. Now next one. It is the first concept how the conductors are defined. In insulators, this band gap is very much higher. This band gap, this energy gap is greater than 5 electron volt. It is greater than 5 electron volt. Now, this one is conduction band, this one is valence band. So we cannot transfer the electron or the electrons from valence band cannot transfer to conduction band. It cannot transfer to conduction band. Okay, because energy gap is very much higher. It is greater than 5. 5 is minimum. Okay, but in semiconductors, like this electron is in home. It is in his house. And he wants to catch the train. Now train is on the tracks near the platform. Okay, is on the track and it is on near to the platform. And the person which is at home, which is far away from the railway station, how it will catch the train? Because this distance is too much large. First, you have to catch the aeroplane. You have to take the plane flight to catch the train. Okay, na? In case you go station पर पहुंच सकते हैं. Now, in case of semiconductors, what will happen? This is conduction band, this one is valence band, and the energy gap is nearly 1 electron volt. Energy gap is nearly 1 electron volt. Electron volt is the unit of what? Energy. Charge into volt. How? You know what is unit of energy? It is VIT. VIT. Energy is VIT. I can be written as charge upon time into time. Time will get cancelled. So it will be V into Q. Charge into Q is the energy. This is energy U. Okay, energy, not electric field. Okay, so energy electron volt. Because electron for coulomb and volt for voltage potential difference. Now this is 1 electron. तुम्ही म्हणा सर 1 आणि 5 मध्ये जास्त काय अंतर नाहीये. तो दोन्ही मध्ये कंडक्ट व्हायला पाहिजे. But this is nearly 1 electron volt and this is greater than 5 electron volt. म्हणजे ही 20 electron volt पण असू शकते, 100 electron volt पण असू शकते, 1000 electron, anything. Okay, 5 is the minimum, not the maximum. And this is nearly 1.1 electron volt, that it may be above 1 or below 1, plus minus 1. So, near approximate 1. So here, by some external influence, the electron can easily transfer from valence band to conduction band. They can easily move. So some passengers are on platform. If anybody siren, if train or some announcement made by a lady on lady by railway department, then the passenger, sorry for some technical problem. Now the energy gap is very less, so it can, by external influence, the electron in valence band can easily move to conduction band, and these are semiconductors. So energy gap is very less, it is around 1 electron volt. Make a note, for silicon it is 1.21. So I will give you exact figure. So at 0 Kelvin and at 300 Kelvin, Okay, for silicon and germanium, it is 1.12 and 1.21 electron volt. It is 0.78 electron volt. It will be 0.71 electron volt. Okay, 0.71 electron volt. So these are the standard electronic volt of silicon and germanium. Okay, 0.71 to 72 near about. Okay, volt लिहिलं का इथं 0 केल्विन ला जास्त असतो आणि इथं कमी होतो. As temperature increases, this gap reduces. Gap reduces means what? The energy needed to go from valence band to conduction band reduces. That means energy will be acquired by electrons in valence band. Valence band मध्ये electrons energy acquire करतील and they move होतील conduction band मध्ये. The electrons will become unstable. ठीक है? So based on conductors, insulators and based on the band gap energy we have classified the material into three parts: conductors, insulators and semiconductors. Okay, so in conductors the two bands are overlap each other. In insulators the band gap between these two is greater than 5 electron volt, and in semiconductors it is nearly 1 electron volt. Data I have given you: silicon at 0 Kelvin it is 1.21 electronic volt, and at 300 Kelvin it is 1.12 electron volt. For germanium it is 0.78 electronic volt and 0.72 electron volt. See, it is just above the one and it is just below the one. That means it is near to 1 electron volt. ठीक है? 0.78 20 तक खाली है, 0.21 20 तक वरती, 0.20 0.20. ठीक है? 0.20. So now we'll see some few properties you can write down below it. ठीक है? About conductors. So here flow of current is because of electrons only. Flow of current is because of electrons only. Ignore no flow of electrons, no flow of current. Okay, then अब मी आता हे करतो याला त्रास करू तुम्ही सगळं लिहून घ्या. Write everything whatever given is on the board. So these are the classifications. Now in detail we will see the properties of conductors, insulators and semiconductors. Now flow of current is due to electrons only. Is due to electrons only. Here then, here no flow of current, no flow of current. And in semiconductors, flow of current is due to electrons and holes. What are these holes? What is mean by hole? We'll study. Okay, electron means electron, and if electron is not there, vacancy is there. Vacancy, not valency, vacancy. That vacancy is called hole. Lack of electron. Okay, lack of electron is called hole. So we'll see. Now flow of current is due to electrons only. No flow of current. Flow of current is due to electrons and holes. दोघांमुळे semiconductors मध्ये. Next thing, in conductors, as temperature increases, what will happen? Molecules starts vibrating up and down like in transverse motion, transverse wave. Okay, up and down they will vibrate and it will create opposed to flow of electron. Molecules will vibrate up and down असे व्हायब्रेट होतील. इफ यू इन्क्रीज द टेम्परेचर इन्क्रीज झाल्यामुळे मॉलिक्यूल व्हायब्रेट होतील and it will oppose the flow of electron, and as it opposes the flow of electron च्या opposite कोण असतं? flow of current, because electron negative charge असतो. ठीक आहे. So here conductivity reduces. So conductivity. So first of all I will write resistivity increases. Resistivity or resistance increases, and which leads to conductivity decreases. So see, as temperature increases, resistance increases. So I can write here it has positive coefficient of resistance. कसला positive coefficient? Temperature coefficient. Okay, it has positive temperature coefficient. त्याचा temperature नुसार resistance निघतो आहे. It has positive temperature coefficient. of resistance. Positive म्हणजे काय? टेम्परेचर इन्क्रीज झाल्यानंतर रेजिस्टन्स पण इन्क्रीज होणार आहे. Next, flow of electron is due to electrons only. Examples. In this example, most of the metals, water, brine solution. So many examples are there. Human body. Okay. Now here, no flow of electron. And one more thing inside this, say as the temperature increases, resistance will increase and conductivity decreases. मग मला सांगा, as the temperature decreases, what will happen? Temperature increase झाल्यावर conductivity decrease झाली. मग temperature decrease झाल्यानंतर conductivity काय होणार? Increase होणार. So at 0 Kelvin, it will be superconductor. What is mean by 0 Kelvin? 0 Kelvin, you know, it is minus 273 degrees Celsius. 0 Kelvin means minus 273 degrees Celsius. If you can achieve this temperature, that's why most of the people say superconductor is not possible. Why? सुपरकंडक्टर कुठलाही मेटल जो आहे ना तो सुपरकंडक्टर होऊ शकतो. सुपरकंडक्टर असा कुठला मेटल नाही आहे, तोच मेटल सुपरकंडक्टर म्हणून ऍक्ट होऊ शकतो. इफ यू कॅन अचीव minus 273 डिग्री सेल्सियस. सो ऍट 0 केल्विन म्हणजे टेम्परेचर कमी होत जाणार, तसं कंडक्टिव्हिटी इन्क्रीज होत जाणार. काय रिव्हर्स आहे ना. सो टेम्परेचर जसं 0 केल्विन होणार म्हणजे minus 273 डिग्री सेल्सियस होणार, त्यावेळी it will become superconductor. Now insulators. In insulators, no flow of current. So what is the reason? We don't have to study whether it is due to electrons or whether it is due to holes. So here it is due to electrons, here it is due to electrons and holes both. Now as temperature increases, here resistance decreases. Why? And conductivity increases, which leads to conductivity increase. Why? But in little amount, in very little amount. What will happen here? As if you increase the temperature, the electrons which are in valence band, okay, the bond between that electrons and nucleus will break. You are increasing the temperature, that means you are giving the energy to that electrons, those electrons which are in valence band, which are bonded to nucleus. You are giving energy, you are giving temperature. Temperature means heat. You are giving temperatures means you are heating. That means you are providing energy. And if you are providing energy to electrons in valence band which are stable, that will become unstable. That means it will become free, so that it can conduct electricity, but in very less manner or very small amount of energy it can flow. Next we can say it has, so as temperature increases resistance decreases, so we can say it has negative temperature coefficient of resistance. Negative temperature coefficient of resistance म्हणजे as temperature increases resistance decreases. Okay, next one example we know example क्या है, wood, rubber, so many examples are there. Then example अंदर क्या है, हाँ, at 0 Kelvin, what will happen at 0 Kelvin? Now see, as the temperature increases, conductivity will also increase. Temperature increases, conductivity also increases. So as temperature decreases, conductivity also decreases. So at 0 Kelvin, so 0 Kelvin is minus 273 degrees Celsius. So at 0 Kelvin means you are going to decrease the temperature, hence conductivity will also decrease. So insulator can insulator. So it will remains insulator. It remains insulator. तो इन्सुलेटरच राहणार आहे, कारण का इन्सुलेटरची तुम्ही कंडक्टिव्हिटी आणखी कमी केला तर काय होणार, तो सुपर इन्सुलेटर होणार, म्हणजे इन्सुलेटरच होणार आहे. ठीक आहे ना. नेक्स्ट here flow of current is due to electrons and holes. Now okay, this is the first characteristic. Second one, as temperature increases, here also as temperature increases resistance will increase, which leads to conductivity, resistance decrease, which leads to conductivity increase. Here also as temperature increases resistance decrease. Why? The same reason, as we are providing temperature to the electrons which are in valence band, they will receive the energy and becomes unstable. Acquire the energy and becomes unstable, and when they become unstable they will become free themselves and move to the conduction band. And as they move to the conduction band, they will conduct electricity. Okay, so this is, so here also we can say it has, so as temperature increases resistance decreases, it has negative temperature coefficient of resistance. It has negative temperature coefficient of resistance. नेगेटिव है ना, उल्टा है, टेम्परेचर वाढल्यावर रेजिस्टन्स कमी होतो. एक्चुअली काय आहे टेम्परेचर कोएफिशिएंट म्हणजे काय आहे, dr/dt. This is positive or negative. This temperature coefficient means, temperature coefficient of resistance means dr/dt. Like see, if resistance increases temperature will also increase, or temperature increases resistance also increase. दोन्ही increase म्हणजे चेंज काय होणार, चेंज डेल्टा means change means final minus initial. If final increases means final is more, final minus initial will be positive, and this will be also positive. So what will happen, the whole will be positive. But in this case, as temperature increases resistance will decrease, so temperature increases means delta T is positive, final is more than initial, so final minus initial is positive. But resistance decreases, that means final is lower, final is smaller, so final minus initial, smaller minus lower is negative, so negative upon positive will be negative. So this is negative temperature coefficient of resistance. Next example, silicon, germanium. Then there are mixtures of silicon and arsenic, silicon and indium. We'll see. These are the examples. Okay, at 0 Kelvin, what will happen? At 0 Kelvin, see temperature increases, conductivity increases. Okay, as temperature increases, conductivity will increase. So as temperature decreases, conductivity will also decrease. So at 0 Kelvin means you are decreasing the temperature, hence conductivity also decrease. So as conductivity decreases, so semiconductor becomes insulator. Okay, so at 0 Kelvin, it will become insulator. It will become insulator. Okay, so this is about classification of what is semiconductor, what is conductor, and what is insulator. Okay, now we will see semiconductors, classification of semiconductors. Now, conductor, insulators are आपको study करना है. We are now focusing on semiconductors. This we have studied most of the times in your lower classes. Now we are going to see what is semiconductors. Semiconductors are divided into two parts. Actually, you know, semiconductors materials semi म्हणजे middle, ठीक है, half semesterism. So the total maximum valency is 8 and minimum valency is 0. Okay, so in between which valence is there? 4, and that type of materials are called semiconductors. Valency 4 materials. So valency 4 materials like carbon when it is in graphite form, then it's also semiconductor. So but due to some reasons, carbon is reactive towards oxygen and forms carbon monoxide, carbon dioxide. Various reasons are there. So we use silicon, which is having some different properties of conductivity. Okay, better than carbon. So most widely used is silicon. Silicon is below the carbon. In periodic table, it is below the carbon, which is also having the valency 4. That is called semiconductors. Always remember, semiconductors are material, pure semiconductor, pure semiconductor. So the materials which are having valency 4. Okay. Now these semiconductors are classified into two parts. बघा हे क्लासिफिकेशन आहे याचा अर्थ इम्पॉर्टंट नाही असं नाही, मी सांगतोय ते सगळं लिहून घ्या, जे बोलते ते पण लिहून घ्या. Now it is classified into two parts. The first part is intrinsic semiconductor. Intrinsic semiconductors. And the next part is extrinsic semiconductors. Intrinsic semiconductors and extrinsic semiconductors. These are the two parts. Now, extremely pure semiconductor. Extremely pure semiconductor is called intrinsic semiconductor. Extremely pure means valency 4. So write down here extremely pure semiconductor. Extremely pure semiconductor. Semiconductor is called intrinsic. Example: silicon, germanium. Silicon and germanium. Valency 4. दोघांची पण valency 4 आहे. Silicon and germanium. ठीक आहे. इथं X आहे, EX आहे, इथं EX आहे, म्हणून याच्या खाली हे लिहू नका. कसं म्हणायचं? एक्स्ट्रीमली प्युअर म्हणजे इंट्रिन्सिक. इंट्रिन्सिक म्हणजे इंडिपेंडेंट. इन आहे ना, इथं एक शॉर्टकट सांगतो, लक्षात ठेवा. In for independent. इंडिपेंडेंट म्हणजे काय, बाहेरचा कोणी फॉरेन पार्टिकल आलाय का, बाहेरचा कोणी फॉरेन पार्टिकल आलेला नाहीये, तो इथं कुठे आलेला नाही, त्यामुळे तो एक्स्ट्रीमली प्युअर आहे. इंडिपेंडेंट आहे म्हणून एक्स्ट्रीमली प्युअर आहे. आणि इथं एक्सट्रिन्सिक आहे. एक्सट्रिन्सिक म्हणजे काय, एक्स्ट्रा कोणतरी आलेलं आहे, एक्स्ट्रा एक्सट्रिन्सिक सेमीकंडक्टर. आता इथं EX आहे, इथं EX आहे म्हणून मोस्ट ऑफ द स्टुडंट याला इकडे लिहितात, उलट करतात. मग इथं तुम्ही एक्स्ट्रीमली हा वर्ड डोक्यातून काढून टाका. इथं तुम्ही इतकं लक्षात ठेवा, प्युअर सेमीकंडक्टर इज कॉल्ड इंट्रिन्सिक. नाउ प्युअर म्हणजे काय, इंडिपेंडेंट, त्याच्यामध्ये कुठली इम्प्युरिटी नको आहे, बाहेरून कोणी आला नाही पाहिजे, तो इंडिपेंडेंट पाहिजे, स्वतः पाहिजे, इंडिपेंडेंट, तर त्याला आपण प्युअर म्हणतो. तर हा वर्ड तुम्ही डोक्यातून काढा. बट एक्स्ट्रीमली प्युअर, तर प्युअर असला पाहिजे, तर तो कशाच्या अंडर येतो, इंट्रिन्सिक सेमीकंडक्टर. नाउ इम्प्युअर सेमीकंडक्टर आर कॉल्ड एक्सट्रिन्सिक सेमीकंडक्टर. एक्स्ट्रा काहीतरी एक्स्ट्रा आलेलं आहे, इम्प्युरिटी आलेली आहे, इम्प्युरिटी. ठीक आहे. So why we need extrinsic semiconductor? Even though if you are having pure semiconductors, so what is the need of impure semiconductors? Actually, you know, we are widely used impure semiconductor, that is extrinsic semiconductors. These are of our use. इथं आपलं नुकसान आहे. Even though semiconductors are pure, they are pure, still we don't have very much use of this type of semiconductors, but extrinsic semiconductors which are very widely used. What is the reason I will tell you? Now, this extremely pure semiconductors are called intrinsic semiconductor. Examples take on germanium. Put it doesn't conduct electricity किंवा doesn't conduct current, electricity at room temperature or atmospheric temperature. It doesn't conduct electricity at room temperature. This is the problem. Okay. Now one more property of semiconductor we have studied. What is the property of semiconductor? Sanga, if temperature increases, resistance decreases, conductivity will increase. As you increase the temperature, the energy will be acquired by electrons in valence band, and the valence band electrons becomes free, becomes unstable, and they can carry the electricity. So as temperature increases, resistance will decrease and conductivity will increase. But lakshya diya, ata between the two poles, this is a straight poles which are carrying electrical cables from Koina power plant, okay, from dam where idle power plant where energy has been generated using water, air, wind, and from there electricity is being conducted with the help of aluminum wires. Okay. Instead, road wires asतात, and in place of that wires, metal wires, if I use semiconductor, pure semiconductor, so see, it doesn't conduct electricity at room temperature. That means it will not conduct the electricity, first point. Now to make it conduct the electricity, we need to increase its temperature so that resistance will decrease, and then what will happen? Its conductivity will increase. So बघा किती जोखमीचं काम आहे. तुम्हाला करंट फ्लो करायचा आहे, त्यासाठी टेम्परेचर वाढवावं लागेल. टेम्परेचर वाढवायचं म्हणजे हीट द्यायचं. हीट देण्यासाठी बघा तुम्ही घरी पाणी गरम करता, वॉटर हीटर असतो, or to increase the temperature of room in winter season we need to use room heater or air conditioner. That means we have to heat something or to increase the temperature of some body, we need to give supply, we need to supply heat. And supply of heat can be generated by wasting the electricity. That means wastage of any one power, any one energy. एक कुठली तर एनर्जी तुम्हाला वेस्ट करावी लागणार. That wires have to be continuously given heat. जी वायर आहे ना दोन पोल्स मधली, this is the wire, ठीक है, which conducts the electricity from one place to one place. These are the two towers or poles. Now here we have to continuously supply the heat. Suppose these are the burners. We have to continue supply the heat to the wires, so the temperature of the wire will increase and then it will conduct the electricity. That means to conduct the electricity, we are wasting the electricity. चांगला आहे का ही गोष्ट? नाही ना, म्हणजे इलेक्ट्रिसिटी फ्लो करण्यासाठी इलेक्ट्रिसिटी वेस्ट करायची गरज आहे. इलेक्ट्रिसिटी जर फ्री मध्ये जर फ्लो होत असेल तर इलेक्ट्रिसिटी वेस्ट करायची काही गरज नाही. सो इथं तुम्ही एनर्जी वेस्ट करत आहात. सो फॉर दिस important point that pure semiconductors does not conduct electricity at room temperature, and to make it conduct the electricity we have to increase the temperature. So as temperature increases, resistance will decrease and hence conductivity increases. One more point to remember here, M is equal to P. What is P? Concentration of electron is equal to concentration of holes, or you can say number of electrons is equal to number of holes. Number of electrons is equal to number of holes. H holes म्हणजे lack of electron. म्हणजे फॉर एक्झाम्पल समजा इथे इलेक्ट्रॉन आहे, दिस इज इलेक्ट्रॉन, ही इलेक्ट्रॉनची एक प्लेस आहे, हा इथून निघून इथे गेला, तर आता काय झालेलं आहे, इथे इलेक्ट्रॉन आला आणि इथं काय झालंय, एक वॅकन्सी क्रिएट झाली, इथं एक होल क्रिएट, दिस इज कॉल्ड होल. लॅक ऑफ इलेक्ट्रॉन, this is called hole. So generally student take it as negative and here it is as positive, because it is gain of electron positive and loss of electron hence negative. Okay, it is just to remember. So electrons, number of holes and number of electrons are same in intrinsic semiconductor. Now we'll see what is extrinsic semiconductor. So in intrinsic semiconductor the current flow is due to both, here both are same na, conductors and electrons and holes are same, so flow of electron, flow of current is due to both electrons as well as holes. Now we'll see what is extrinsic semiconductor. Now here we draw करतो, and here I will draw intrinsic semiconductor. This is silicon. Okay. Now this silicon is having 4 electrons in outermost shell. I am showing only the outermost shell electrons. Silicon atomic number किती 14, बरोबर का 16, sulfur 16, हाँ 16, 14. Okay, so 4 electrons in outermost shell, 2, 8 and 4. Okay. Now it is surrounded by silicon atoms in all sides. two electrons share bond, covalent bond. Here these two electrons, here the two electrons, here, here. These are the covalent bonds. Sharing of electrons. याच्या खाली पण सिलिकॉन मॉलिक्युल्स असतील बिकॉज 10 raised to power 23 मॉलिक्युल्स असतात एका मोल मध्ये 6.023 into 10 raised to power 23 Avogadro. According to Avogadro's 1 mole of molecule contains 6.023 into 10 raised to power 3 molecules. Okay, 10 raised to power 23 म्हणजे किती 10 over 23 झिरो लाख नाही हजार नाही लाख नाही करोड नाही अब्ज नाही अब्ज म्हणजे 6-7 शून्यापर्यंत जातो 6-7 झिरो 23 झिरो तितके झिरो तेवढे मॉलिक्युल्स असणार आहेत तर ठीक आहे आपण पुढे काय ड्रॉ केलं सगळे मॉलिक्युल एकमेकांना सॅटिस्फाय करतात बिकॉज 4 व्हॅलेन्सी आहे आणि 4 साइडला भेटतात आपल्याला and 4 has become मध्ये किती झाले 8 झाले का 1 2 3 4 5 6 7 8 हा इकडचा इकडे कुठे शेअर करत नाही इकडच्या सिलिकॉन कुठे शेअर करत नाही हा इकडचा इकडे कुठे सिलिकॉन असणार आहे कंटिन्यू असणार आहे ठीक आहे सो दिस इज प्युअर सेमीकंडक्टर नाउ इन प्युअर सेमीकंडक्टर वी डोंट हैव एनी लूज इलेक्ट्रॉन because all 4 electrons of silicons are surrounded by silicon particles and get bonded with surrounding 4 electrons. Hence, there is no free electron in intrinsic semiconductor. Hence, it is do not conduct electricity at room temperature. So, if we increase the temperature, then resistivity increases. How? Any one of the electron gets free. That means it moves from valence band to conduction band. Valence band to conduction band जाणे म्हणजे काय? हा बॉन्ड ब्रेक करणं आणि बाहेर येणं आणि कंडक्ट करायला मदत करणं ठीक आहे ना दिस इज intrinsic semiconductor that is pure semiconductor now we'll move to extrinsic semiconductor in extrinsic semiconductor if impurity is added or process of adding impurity if impurity is added to intrinsic semiconductor if impurity is added to intrinsic semiconductor then it is called extrinsic if impurity is added then it is called extrinsic extra काहीतरी बाहेर external आले then it is called extrinsic semiconductor. Now the process of adding impurity, the process of adding impurity is called doping. Process of adding impurity is called doping. Okay. So where we have studied doping, have you heard that doping? Like athletics वाले जे पर्सन असतात 100 meter running, okay, or 4000 meter running, athletics वाले जे पर्सन असतात खेळाडू असतात ठीक आहे ना आपण ॲथलेट म्हणतो त्यांच्यावरती डॉपिंगची केस होती किंवा आपल्या स्लर्स जे असतात कुस्ती खेळताना डॉपिंगची केस म्हणजे काय एक्सटर्नल जर तुम्ही काही घेत असाल स्टेरॉइड वगैरे ड्युरिंग द रेस तुम्ही बिफोर द रेस तुम्ही जर काही स्टेरॉइड घेतला असेल एक्सटर्नल थ्रू द इंजेक्शन और थ्रू द टॅबलेट ठीक आहे असं काही जर तुम्ही घेतलं असेल एक्सटर्नल गोष्ट त्याला म्हणतात डॉपिंग द प्रोसेस ऑफ ॲडिंग इम्प्युरिटी काय तर तुम्ही आपलं घेतलं त्याच्यामुळे तुम्हाला एक्स्ट्रा पॉवर मिळणार आहे and this process is called doping that is not doping ची केस म्हणतात ओके बरं तुम्ही ऐकलं असेल नसेल तर बघा तुम्ही इंटरनेटवर सर्च करा बरेच ॲथलेटिक्स वाले जे आहेत स्पोर्ट्समन ते अडकले अशा केसेस मध्ये डोपिंगच्या ओके नाउ if impurity is added to intrinsic semiconductor, then it will become extrinsic. The process of adding impurity is called doping, and doped semiconductors are called extrinsic. That's it. Same meaning. If impurity added to intrinsic, it will become extrinsic. Process of adding impurity is called doping, and doped semiconductor is called extrinsic. Dop केलेला extrinsic. Dop केलेला म्हणजे काय? Impurity added केलेला. Now these impurities of two types. Impurity is of two types. कोणते types आहेत? Tetravalent impurity and trivalent impurity and pentavalent impurity. Silicon and germanium are tetravalent. Tetravalent means valency 4. So if we add trivalent and pentavalent impurity, then the semiconductor becomes extrinsic. So there are two types of impurities. Impurity चे दोन types पडतात. Impurity चे कोणते कोणते? एक आहे pentavalent आणि एक आहे trivalent. एक्झाम्पल काय आहे पेंटावॅलेंटचं? तर एक आहे आर्सेनिक, एंटीमनी, बिस्मथ. ट्रायवॅलेंटचे एक्झाम्पल इंडियम, गॅलियम, अल्युमिनियम. लिहून घ्या काय म्हणतोय बघा. आर्सेनिक, एंटीमनी, Sb म्हणजे एंटीमनी, ओके. बिस्मथ, Bi. इंट्रिन्सिक चे एक्झाम्पल सिलिकॉन एंड जर्मेनियम. आर्सेनिक, Sb म्हणजे एंटीमनी, Bi फॉर बिस्मथ, Iron for indium, Ga for gallium, and Al for aluminium. Okay, so these are the, so why it is called pentavalent? Because valence is 5. Valence is 5. That means there are 5 electrons in outermost orbit, outermost shell. And here that trivalent. Why trivalent? There are 3 electrons in the outermost shell. That is indium, gallium, and arsenic. बघा वॅलेन्सी 3 असणं आणि ट्रायव्हॅलेंट असणं यामध्ये फरक आहे. 3 व्हॅलेन्सीचा आणि कोण आहे? नायट्रोजन आहे ना 3 व्हॅलेन्सीचा. पण त्याच्या आउटरमोस्ट शेल मध्ये किती इलेक्ट्रॉन आहेत? किती आहेत? 5. पण व्हॅलेन्सी 3 आहे. मग तो पेंटाव्हॅलेंट आहे की ट्रायव्हॅलेंट आहे? इट इज पेंटाव्हॅलेंट. सी व्हॅलेन्सी इज 3. नायट्रोजनची व्हॅलेन्सी 3 आहे पण तो पेंटाव्हॅलेंट आहे कारण त्याच्या आउटरमोस्ट इलेक्ट्रॉन म्हणजे 5 सेल्स. तो व्हॅलेन्सी इज डिफरंट. While calculating valency we are saying minimum. So out of 5 and 3 is minimum, so we can say 3 is the valency. जर 3 इलेक्ट्रॉन मिळाले तर तो काय होईल? ऑर्बिट कंप्लीट करेल. Okay, and 7 are the valence electrons, 5 are the valence electrons, and that is called pentavalent. So in case of nitrogen different होती बरोबर आहे की व्हॅलेन्सी डिफरंट होती आणि पेंटाव्हॅलेंट पण होतो आपण त्याला व्हॅलेन्सी 3 होती. बट इन केस ऑफ सोडियम किंवा दुसरा कुठला घेऊया आपण इथे बघा अल्युमिनियम घेऊया. अल्युमिनियमची व्हॅलेन्सी किती आहे? 1 आहे. एकच इलेक्ट्रॉन आहे ना आउटरमोस्ट मध्ये 3 आहेत इलेक्ट्रॉन्स. सो 3 इलेक्ट्रॉन्स पण आहेत आणि तो ट्रायव्हॅलेंट पण आहे. इलेक्ट्रॉन्स पण 3 आहेत आणि ट्रायव्हॅलेंट पण आहे. ठीक आहे. सोडियम, मॅग्नेशियम. सोडियम व्हॅलेन्सी पण 1 आहे आणि तो मोनोव्हॅलेंट. मॅग्नेशियम व्हॅलेन्सी 2 आहे आणि तो डायव्हॅलेंट आहे. अल्युमिनियम व्हॅलेन्सी 3 आणि तो ट्रायव्हॅलेंट आहे. म्हणजे इलेक्ट्रॉन्स पण 3 आहेत व्हॅलेन्सी पण 3. पण तिकडचे जे असतात आफ्टर व्हॅलेन्सी 4 तिथं जरासं बदलतं. व्हॅलेन्सी नायट्रोजनची ऑक्सिजनची व्हॅलेन्सी 2 आहे पण ऑक्सिजन इज हेक्साव्हॅलेंट. 6 electrons are there. Okay. Then fluorine. Fluorine ची valency 1, single valency, but it is heptavalent. 7 electrons are there, right? Now intrinsic semiconductor. Now if there are two impurities, like pentavalent and trivalent. Let's see what is the time now. Okay, so up to this, today we'll stop here. Hope you are studying well and don't go anywhere. Stay at home, stay safe, stay healthy. Tomorrow we will continue with this chapter because today time is over. Okay, so for you the homework, one more thing. Homework is write everything whatever I have studied, whatever I have taught you, and make a PDF and send it to my personal number. Okay, thank you very much.